Do you know what solid principles are? What solid stand for? SOLID. That we will learn in this lecture. We will learn how solid works, how solid is necessary into our code base, how solid principles is required to design something. Okay, these things all we can do and learn in this lecture itself. So stay connected, watch till the end. We will get a fun, we will enjoy together, and we will learn in a better way. So let's take a real life example to understand what actually solid stands for and what is solid principles. So I take an example. You have a rubric cube and you have to start a game to balance that cube in a way that the left portion, right portion, top portion, bottom portion take a different color or have a different color. Has everyone know that game, right? Everyone know that game, how this cube positioning happening, and we have to rotate the cube to make it organized. The same way the solid principle work. When we are writing a code, that code might not be a sufficient, that code might not be a well defined. So we have to define that code, we have to separate the body of the code in a way that we have follow some principles, so code will look like better, the code will easy to understand, the code will easy to implement and reusable. For that we are using solid principles. So let's get started. We will deep dive into solid principles. So stay connected till the end of the video. I make sure that it will be a fun video for you. We will take an example, real life example of situations to understand what 5 solid principles are, what S is stand for, what O is stand for. Like this we will learn everything and trying to deep dive into that. And after this I will make sure that you will understand thoroughly the solid principles and you will able to implement in your code base. So देरी ना करते हुए let's get started. So let's start with our first principle, that is single responsibility principle. So let's get started. In that, first you will see what is the class we mentioned. So there is a user class that contain name and email, and there is a constructor of it, and we define two method. One is save user, the second one is process order. So what is the problem in that method? Before going to that, firstly I will explain the real life example of single responsibility principle. Consider you are a librarian and one person in the library is cashier. Both has different type of responsibility. If we combine and give the two responsibility to one person, it will be a hectic, right? Or it will be a non-negotiable, or you can say it will be a chaotic thing. So by doing that, or the separation of the work between the two person, one is a librarian who is managing the book, one is cashier who is selling the book, both are different responsibility. So single responsibility principle means that we have to make sure that our class or object contain a single responsibility or follow a single responsibility principle. So in that, it is a user class, right? So user class contain save user. Yes, save user is a responsibility of user class. But process order, is this the responsibility of user class? I can say no, because process order can be a different thing. It cannot be a user responsibility. Okay. So to separate this responsibility into a separate class, that is called a single responsibility principle, or we are following the single responsibility principle and separating the two work in a separate class. So every class will follow a single responsibility principle. In this example, we are mentioned also that user class is handling both user data and ordering processing. It violates the single responsibility principle because it has multiple responsibilities. We have to make sure that that class contain only a single responsibility. If we want to change that, and make sure that it follow a single responsibility principle. So what we do, we created a user class. This is a user class that is using, or in that we created save user method. That is a single responsibility. And we created one more class, order processor class. In that we are processing the order using a method. So both classes have different responsibility, and every class has single responsibility, and every class is following single responsibility principle that is responsible for only one thing. So if you see here, the separating the responsibility of two classes, user and order processor, we make sure that it follow the single responsibility principle. Now each class has a single responsibility, if you see here. So hope you got the first principle, what it says and how it is helpful to define the classes and to define the roles and responsibility in the class. So let us talk about the second principle, that is open closed principle. What do you mean by open closed here? Before going to that, firstly I will explain the real life example of it, so you will understand better, you will relate to it, and then we will same thing we will do in a class. Okay, so think of an example. You have a smartphone and you have to install new software into that. But for installing the new software, did you change the operating system of it? No, we doesn't modify it. We directly install the new software. Same we have to do in code also. What we have to do when we are adding some new feature, we have to make sure that we are not modifying the existing one. That is related to open and closed principle, and that we can say it is a open and closed principle. It is a class which follow the open and closed principle. So let me deep dive into the code of the class and see how it is possible. So if you see here, we have a payment processor class, okay, which process the payment, okay, process credit card. And in that class we have one more method that is called process PayPal. Now if you see here, this PayPal, now it is PayPal, but after that sometime later it can be Amazon as well, it can be Amazon Pay as well, it can be Rupee as well. Okay, so different type of gateway it can has, but we are all things we are maintaining in the payment processor class. Payment processor is a class which we can say that is handling all these payments by the gateway. But right now we maintain everything in the payment processor class. That violates the rule of open and closed principle, and also it will affect when we have to add the Rupee. It will affect the existing class behavior. That we don't want to do that. For following this principle, we have to modify the class. Okay, so when we are trying to modify, what we did, we created abstract class of payment processor that can be a main class. In that we defined process payment method. That implementation we didn't define. We will define of different type of implementation in different type of classes that doesn't affect the existing ones. Suppose what we did here, we define credit card payment. Okay, we define PayPal payment. Both companies has different format, different structure, different design can be there to process a payment, and we have to make sure that every design or every implementation have a separate logic. Okay, every implementation can have the separate logic, both has the separate logic. And if third came, PayPal instead of PayPal, if Amazon Pay came, we have to maintain the separate logic of that also, because every payload is different, every company is different, every design is different. So we have to make sure that everyone follows the different design, and this design doesn't affect this design, or if the modification happened in credit card payment, so we have to make sure that PayPal payment will stay remain same. So this principle will help these things to do that. If you are in company, okay, or company came with requirement, you have to change the flow of PayPal payment, then you have to go into the class and change this method, that is called process payment. Okay, nothing else need to be changed. It doesn't affect on this process payment method which is inside the credit card payment, okay, or which is inside the Amazon Pay, or you can say any other gateway. So hope you got this, why this principle is very very important in design and how it is helping to separate out the flows. So if the system is very big, that time developer don't need to change everything. It is very simple to go here and change everything. Where what is the feature of the design, it depend upon the requirement, what the requirement came, but it is make this principle make sure that if you are changing one thing, other thing will not affect. So that is the best way you can choose to design anything or design any systems that contain multiple gateway, that contain multiple taxes. In Ola, there are multiple taxes of the drivers. Every country has different type of taxes. In India, we are deducting GST, but in UK, we are deducting VAT. Okay, both are different type of taxes. So to maintain that, we are using this design, and we are implementing different type of taxes in different type of classes, and we are extending the same payment processor as we mentioned here. Okay, so same thing you can say in every design, or you can fit in every design. This is one of the example which I give, that I saw in real time, or that I saw in company, that is in working phase. Okay, so that give you the better understanding of the design or this principle. So let's go into the next principle and see how that principle actually works. So if we talk about the third principle, that is Liskov substitution principle, or you can say LSP. This principle says that object of a superclass should be replaceable with the object of a subclass without affecting the correctness of the program. It's like swapping different Lego pieces that fit perfectly together. Okay, let me see in class how it is behaving and how it is really means, and you can understand better by seeing the low level code. So if you see here, we have a vehicle class, okay, and we have a electric class that extend the vehicle class. Means this start method we have to override, that we are doing here. Okay, in that method, if you see here, electric cars do not have the engine to start. Electric car don't have an engine, so that time we are throwing the exception. Okay, means that method is not defined till now. Okay, so if we have to maintain the LSP principle, then we have to change some of the things. If I go here and see, so we have the vehicle class, we have the electric cars that extend the vehicle class, and we have a method that we are overriding, that is start engine. So we are implementing the engine logic for electric cars. Okay, and starting electric engine, and that engine will start. Okay, that means that this is a parent class. Okay, this electric class car can be a different, this can be a petrol car. Okay, this is one more car, or this can be a diesel car. Okay, this can be a diesel car. This is a class, new class, this is new class. Every class extend the vehicle class, that we have to make sure that every class is extend the vehicle class. Okay, and we have to override this start engine method in every class. We have to override start engine method. Okay, we are overriding start engine method to make sure that this engine is different, this engine is different, and every engine is different. For managing these things, we are following Liskov principle. Okay. So if you see here, by implementing the start engine method in electric car, we follow the LSP. Okay. Ensure that subclass can replace the superclass without issues. And also, to understand this LSP principle, I can give a real life example too. You can say you have a remote control from which you can run or switch on, switch off any TV. Same remote control will work for every brand's every TV. That is a global remote control. Okay, that remote is working everywhere. Same thing we have to do for classes. Subclasses should be interchangeable with their superclasses. Okay, without breaking the application. So using subclass, you can make the superclass object. That it means when you are learning the inheritance, that time these things will come. Using derived class object, you are making the base class object, or using base class object, you are making the derived class object. So this is the principle which Liskov follow, and you have to override that method. So that come under Liskov principle. So now let us learn interface segregation principle, and it is very important principle used in every company, everywhere, in day-to-day life basis, and you also have to implement in your code base when you are seeing such situations. And it is very helpful. Whenever I saw something, firstly I will think about this principle, because this principle can be fit everywhere, every situation, and many situation it will fit. Okay, we have to make sure that this principle we have studied a lot, we have learned a lot in deep and understand it, okay, properly. So let us start interface segregation principle. What interface segregation principle actually means? Interface segregation principle advises that no client should be forced to depend on method that does not use. This means creating a specific interface for different functionalities. It's like having different tools for different tasks in your toolbox. That is very interesting problem. Okay, let's see the violation of interface segregation principle and how we have to apply it correctly along with a real world analogy. Okay, we will explain everything. So if you see here, large interface with unrelated method. Okay, large interface with unrelated method. We have an interface worker. Okay, that do work, that do eat. Worker can do both, but suppose worker can be machine, so machine can eat? No, machine can't eat. So that time this method will be non-useful, or this method will be a redundant for this robot. Okay, for this robot, because robot can't eat. Okay, so for doing that, for this reason, it violates the interface segregation principle, and we have to split that worker interface into two parts. Okay, we will do that. So if you see here, we have a workable interface that will work, we have a eatable interface that will eat. So whenever, if employee is there, we have to implement both, because employee can work, employee can eat. But if you see in robot class, it can only implement workable because it can work, but it cannot implement eatable because robot can't eat. Okay, can't eat, robot can't eat. You have to make sure that. So like this, you can follow this principle to segregate the things, not to mix up, segregate the thing in a simple way that you can implement or that you can use for your better way. So let's take a real life example of interface segregation principle. So suppose you are going the restaurant. Okay, restaurant contains some menus, it contain some menu. Okay, menu can be food menu. Okay, menu can be drink menu. Okay, two types of menus are there. So suppose if they give you a single menu, it will be a difficult, right, to find out the things, or it will be a messed up. So they segregated two menus, one menu into two parts. That is called, and that follows the interface segregation principle. Okay, hope you got it right now, where it is used, how it is used, and what is the real life example of it, and how we can separate the classes using interface segregation principle where it is necessary to do that. Okay, so let us understand the last principle of solid, which is called as dependency inversion principle. And this thing in Spring, in the AutoWire framework or AutoWire annotation, you can see this is also an injection type of thing which is happening in Spring Boot. If you learn Spring Boot, this thing is followed there. Okay, and this thing you have to follow in your code base also. So let us get started. We will see first how this dependency inversion principle look like. So let's get started. So let us see. Dependency inversion principle suggests that high level module should not depend on low level modules. Both should depend on abstraction. This is like a building a house on a strong foundation rather than on a sand. This is very interesting problem. Okay, and that is very interesting problem statement. So if you see here, it violates the DIP principle, that is dependency inversion principle. How it will violate? Let's see. So we have credit card payment. Okay, in that we are process the amount. Okay, process credit card payment, and we have shopping cart. There we are making the object of credit card payment and directly process it. So in that case, what is happening? In that case, this credit card payment totally depend upon the shopping cart, or it is highly dependent. We have to make sure that it is depend upon abstraction, not the definition of it. Okay, so let's see how we can manage that. So if you see here, what we did, we created one interface that is called as payment processor interface. Okay, in that payment processor interface, we define one method that is called process payment, and that process payment method, what we define there, we will use that method to implement in every class, whether it is credit card payment, whether it is different payment. Okay, so when we are making the shopping cart object, what we are doing, we are creating the payment processor object. Payment processor is what? Payment processor is interface. It doesn't contain any definition. It is just a declaration statement. Okay, and then here, based on the shopping cart, whatever object we need to pass, whether it can be credit card payment, whether it can be Amazon Pay payment, whether it can be debit card payment. Okay, this type of classes we have to pass here, and this object can load that class. And when we are doing a checkout of shopping cart, it doesn't matter we are doing using a credit card, debit card. At runtime, it will decide what class is picked, and that process payment method is called. Okay, and if you see here, in above case, when we are doing a shopping cart, we are directly including credit card payment method. That means that at runtime we can't do UPI, we can't do Rupee payment. Okay, because we hard coded this thing. But here, using an interface, this is an interface object. Using an interface object, we have to make sure that we are making sure that this interface can load any class. It can load a credit card payment, it can load a Amazon payment, it can load a Visa payment, based on whichever the classes are implementing this interface, that can load here, and this process method is called. So by doing that, by using an interface payment processor, we ensure that shopping cart depend on abstraction rather than concrete implementation or hard code implementation. And it follow DIP principle, that is called dependency inversion principle. So that's it. our video is ended here. We explain all the 4 principles, whatever it is, like solid, all the 5 principle we explain, like as what S is stand for, what O is stand for, what Li is stand for, what D is stand for. We explain everything. So hopefully you like the video. If you like the video, share with your friends, and whatever doubts you have, mention in the comment section. Also, we have the Telegram group. You can join there and ask me anything, whatever you like to ask, and whatever you have the doubts, and you can put a comment also. I will reply there. Okay, share with your friends if you like the video. So मिलते हैं नेक्स्ट वीडियो के साथ, तब तक के लिए टेक केयर, बाय बाय, सी या, हैव अ गुड डे.